Okay, let me check. JNV, KNR, JNV Krishna, JNV Mahe, JNV Vardha. Okay, good evening. Okay, so today we are going to start mechanical properties of fluid. Previously, we have completed mechanical properties of solid. You can watch the lectures. Very good evening, JNV Mahe. Okay, so this is a more of a conceptual chapter, and you need to memorize few of the things. You need to remember few of the things, few of the punchlines, keywords, everything that you need to remember, so that while solving the numerical problems, it will be easier for you to solve. So I think we should wait for 1 or 2 minutes for time, and after that we will start. Okay, now, so let's start the session. First of all, first thing about is fluid. What is fluid? In the previous chapter, we have learned about solids, properties of solids that can sustain shearing stress. You know about the shearing stress. Now, what is fluid? Fluid is something, a substance which can flow. Fluid is a substance which can flow. If you apply a tangential force, look at me. If there is a fluid, there is a substance. I'm not telling it, I'm not calling it a fluid actually, I'm calling a substance, and you are applying a shearing stress, shearing force on it. Then this substance tends to flow. Such substances are known as fluids. I think word is clear to you. These substances which starts flowing if you apply some tangential forces on them, or you can say if you apply some tangential stress or shearing stress to them, they start flowing. Such substances are known as fluid. In very short term, a fluid is a substance that can flow. This is a very simple definition you can remember. Again, one more thing, they do not support shearing stress. Shearing stress is what? If you apply a tangential force, the shape of the body gets deformed. That's what we have learned in solids, in properties of solids, that if you apply a tangential force, do you remember the tangential force? Do you remember the shearing stress from the previous class, previous sessions of solids? So they do not support, they start flowing. They just don't get deformed, they start flowing. And such a substance is known as fluid. So what you need to remember about fluid is substance that can flow. And what are those substances? Like, for example, if I say most of the liquids and gases comes under the term fluid. Gases and liquids comes under the fluid. So we are going to study these fluids of liquids or gases. Clear? Next. There is another term that is called ideal fluid. When we are studying the fluid, we just deal with, initially we will deal with the ideal fluid. So what is the idea of ideal fluid? What is ideal fluid? Ideal fluid is what? The fluid which cannot be compressed, which cannot be compressed is called ideal fluid. Compressed is what? This non-viscous term we will discuss later in the later section of the chapter. You just need to remember the term non-viscous, or you have studied about it, viscosity term in your classrooms. So we will discuss it later. So now the term is incompressible and non-viscous fluid is known as ideal fluid. I think the term is clear. Incompressible means, what is incompressible? Suppose this is a container. or you can say, let's erase this one. And I'm saying, just consider the situation like this one. This is a tube. Don't go with the drawing. It's a tube. And generally, this tube is known as YouTube, not the YouTube on which you are watching the video. It's a YouTube, this one, as it is YouTube. The shape of the tube is U type. That's why it is called as YouTube. So what I'm saying, suppose this YouTube contains some liquid like this one, like this. And there is a cap, or you can say there is a lid on it, like this way. There is a lid, and this lid is movable. This lid is movable. So what we are doing, if I push this left side, or you can say this is lid A, this is lid B. If I push this lid A in the downward direction by some distance h, by some distance h, then the lid B will rise by the same height h. That means you are compressing the liquid, but actually it's not compressing, it's rising up from the other side. Such a liquid is known as incompressible liquid or incompressible fluid. If it doesn't rise up to h height or up to same height, then this is known as compressible liquid. It gets compressed. I think compressible thing is clear to you. Now, we will move further. Just go through these things on your slide. Each and every term must be clear. What is fluid which can flow? Liquid and gases comes under it. They do not support shearing stress. What is shearing stress? You know that. Ideal fluid is what? Non-viscous and incompressible. That's it. Now, what is fluid mechanics? Mechanics term you are aware of. So what is fluid mechanics? Whenever we talk about mechanics, there are two things come in our mind. That is statics and dynamics. Statics and dynamics. And the definition term is very clear. I don't need to define, I think. Statics is what deals with the properties of fluid at rest. Whenever the fluid is at rest, and at rest fluid means the fluid is contained in a vessel. The fluid which is contained in a vessel. Vessel means a container, like a jar, a bucket. The fluid which is kept at rest. The property it shows are the properties, or they comes in the branch fluid statics. And when the fluid starts flowing, when the fluid starts flowing, the study of that fluid is fluid dynamics. I think the two terms are clear. When fluid is at rest, it is known as, its properties are known as fluid statics, and when it starts moving, its properties comes under fluid dynamics. I think this is another simple topic, simple thing. Now moving further. Now the main thing comes. What is pressure? So now look at each and every term very clearly. Suppose this is a container. This is a container which contains some liquid. You can say water. Sometimes I may say liquid. Sometimes I will say water. Sometimes I will say fluid. All these things are same for the discussion purpose. So this is a fluid. Can you see that the fluid contained in the container? So this fluid is going to be at rest. This fluid is going to be at rest. So what is observed that this fluid or this liquid exerts a force, exerts a force perpendicular to the surfaces. Surfaces are what? Like these walls. These walls are the surfaces. These are called the side walls or the bottom walls, whatever you say. These fluids or this fluid exerts a force which is perpendicular to the walls. Again, I'm saying if I insert a body inside it, any body of any shape, then also this fluid exerts a force perpendicular to the surface always. So, one thing to keep in mind, what is that one thing? When a fluid is at rest, it exerts a force perpendicular to any surface in contact. Remember all these things as the punchlines because it will help you a lot. Sorry. What I'm saying, fluid is at rest. If the fluid is at rest, then it will exert a force perpendicular to the surface in contact. One thing is clear. Now, what is the cause of this force? You can see fluid is at rest, but the molecules inside it are moving. You know that when you have studied about solid, liquid, and gases, you know that molecules of liquid and gases moves randomly. So the cause of this force is the motion of molecules. So in the next line, I have mentioned that this force is exerted by the molecules of the fluid because they are in motion. I think these two things are clear. Now, this force, which force? This force perpendicular to, or you can say this perpendicular force per unit area is known as pressure. This perpendicular force per unit area is known as pressure. Now, I will define pressure in more different way. Again, consider that there is a very small area. This is the area, or you can say we have considered an imaginary area inside the fluid like this. This is a very small area, dA. What I have told you that the fluid near it will exert a force in the perpendicular direction of it, will exert a force in the perpendicular direction of it like this. So what is pressure? Pressure is defined as this perpendicular force per unit area. What is the symbol dF perpendicular? dF is the just it's just notation of force perpendicular or the small force perpendicular to the surface divided by area. So what is dF? Perpendicular force. Perpendicular force. Okay. What I'm saying that at any point or at any area, the force is always perpendicular, and this perpendicular force per unit area is called as pressure. Things are clear. Next thing, which is very simple, we will talk about some units. If you talk about unit, you can find the unit force per unit area. Force is what? Newton per meter square. And this Newton per meter square is generally known as Pascal. is generally known as Pascal. It is named on a scientist. I think Blaise Pascal was his name. So Pascal is the unit, or its symbol is PA. Symbol is PA. So unit of pressure is Pascal or Newton per meter square. One more unit is there. One more unit, or you can say other unit. They are various units. So you don't need to worry about those, but you need to remember one or two units. That is bar. Other unit is what? Bar. It's generally common unit. And what is the relation between bar and Pascal? So 1 bar is equals to 10 raised to the power 5 Pascal. 1 bar is equals to 10 raised to the power 5 Pascal. These are the some basics units of pressure. Whenever you want to calculate pressure, find the force perpendicular divided by area. Always use perpendicular force. You will see it in the nearby concept test or questions. What is pressure? What is the cause of pressure? If someone asks you what is the cause of fluid pressure, what you will reply? You will reply the force exerted by the molecules in motion is the cause of pressure exerted by the fluid. Clear? Moving on the next slide. What are the properties of pressure? There are some basic properties that you need to remember. First property. Pressure is uniform in horizontal plane. Pressure is uniform in horizontal plane. This is again a very simple thing. If I say, just consider a situation. Have a look at that. Let's suppose this is a beaker or a container and it contains a fluid like this. Clear? What I'm trying to say that in horizontal plane or in horizontal direction, pressure is uniform. It will not change in the horizontal direction. That's what I'm trying to say. For that, just consider a very small cylindrical surface inside it. Now, things will go worse if you don't listen. What I'm saying, consider a very small cylindrical portion. What is this cylindrical portion made of? It contains the same liquid. It's imaginary cylindrical surface inside the volume of the container. I have imagined a cylindrical surface. The cross section area of which is A, like this. Cross section area is A. Again, I'm saying, let's suppose on the left face, on the left face of it, there is a force F1, and on the right side of it, there is a force F. These things are clear. I have imagined there is a force on the left side F1, on the right side F2. And this force is always perpendicular. In the previous slide, we have learned that fluid exerts a force perpendicular to the surface. Now, again, I am assuming one more thing. I am assuming what I am assuming that pressure at the left surface is P1 and at the right surface is P2. Clear? Now, tell me one thing. What is the relation between F1 and F2? or what should be the relation between F1 and F2? Because the liquid is at rest, liquid is filled in a container, so it should be at rest, it should remain at rest. And for equilibrium, I will say for equilibrium, this F1 must be equals to F2, right or wrong? You agree or disagree? This F1 should be equals to F2. Because if F1 is not equals to F2, then the fluid will start moving. And actually, it cannot move because it is contained in a container. Clear? So F1 should be equals to F2. Now, again, listen to me very carefully. If F2 is greater than F1, if F2 is greater than F1, then this fluid will start in the direction of F2 and vice versa. So what I'm saying, as the fluid is in equilibrium, so F1 must be equals to F2. P is equals to force per unit area, or you will say P1 is equals to F1 upon area. So what is the value of F1? F1 will be P1 into A. So I will replace the values. F1 is equals to P1 into A is equals to P2 into A. A will cancel out and you will say P1 is equals to P2. P1 is equals to P2. This is what? This is the meaning, the what is the purpose that in the horizontal line, because cylinder was horizontal. So in the horizontal line, pressure remains same. That was the first property of pressure. Clear? Second property. Take some time. If you have any doubt, you can ask. Otherwise, I am moving further. Next thing says, fluids in equilibrium exert pressure perpendicular to the surface in contact. This is again a simple line. What I am saying, consider a container. And if someone asks you what is the direction of pressure at this point A, you will say perpendicular to the surface in contact. So this is the surface. So pressure will be perpendicular to it. At this point, pressure will be perpendicular to it. At this point, pressure will be perpendicular to it. So pressure is always perpendicular to the surface or the contact surface. This is again a second property. Next thing, free surface of a liquid at rest remains horizontal. This is again the same thing you have seen many a times. If you fill a liquid in a container, then the surface you see is horizontal in nature, except at the ends. That is the another phenomena that we will study about surface tension. So just leave it. Otherwise, the surface always remains in horizontal or a plane direction. It remains plane or horizontal. I think this is clear. We have learned very few things till now. What is fluid? What is ideal fluid? What is pressure? What is the cause of pressure and properties of pressure? Try to make note of all these things. The most important property that is written here is this one. Moving further. Okay. What is atmospheric pressure? This is again a very simple term, atmospheric pressure. What is atmospheric pressure? If you have seen a lot of examples in your junior classes, like in 7th, 8th, or whatever classes you were, that there, if you see that Earth is surrounded by, atmosphere, that atmosphere exerts a force on each of the things, like us, like on everything. So it exerts a pressure. That pressure is known as atmospheric pressure. And this pressure is of very important. Our body has adopted to this pressure. Our body has adopted to this pressure. I think you have remembered one or two things, like whenever astronauts go टू दी स्पेस, एस्ट्रोनॉट्स ही जाते हैं ना स्पेस में, या एस्ट्रोलॉजर जाते हैं, एस्ट्रोनॉट्स ना, you call them astronauts, correct me if I am wrong. तो astronauts जब भी स्पेस में जाते हैं, whenever they travel to the space, they wear a special kind of suit, special kind of clothes they wear, because if you go in the space there is no atmosphere, so the atmospheric pressure is not present, atmospheric pressure is not present, so your body will try to expand, because on earth atmosphere is compressing you, and if the atmosphere is removed, you are in a space where there is no atmosphere, then your body will explode. So to avoid such explosions, they wear a special purpose suit or a special suit or cloth which creates the same pressure on your body as the atmospheric pressure at earth. I think you are listening to me. Another thing, some divers means the persons who dives in sea, in oceans, till a very deep, so वो डाइवर्स भी क्या करते हैं, वो भी एक स्पेशल ड्रेस पहनते हैं. Why so? To avoid the extra pressure, because at the depth of the ocean the pressure is very high. So to avoid the compression of the body beyond a certain limit, they used to wear a certain suit or certain cloths, so that the pressure can be minimized, the excess pressure of water can be minimized. So what I'm saying, one thing or more, you will search on the internet. I just can't put the video here. You can search on the internet that effect of atmospheric pressure. There was an experiment. If I can resemble you, there is a body. This is a body. What was the experiment? This is a body. This is a very hard, very solid body. It cannot be broken easily. It has some air inside it. It has some air inside it. The experiment was, they, by some mechanism, by vacuum cleaner, you can also do that. By some mechanism, they pulled out the from the from this bottle. They pulled out the air from this bottle, and it just shrinks. It just shrinks. Why is so? Why it shrinks? Because the atmospheric pressure outside it applied so much force that it just explodes. It just shrinks completely. So you can search on the internet about that. I can't put the video here. So I think you are getting the things, atmospheric pressure. So if I talk about definitions, it is the pressure of Earth's atmosphere. It acts everywhere. It is generally denoted by P naught. Generally denoted by P naught. Somewhere, some persons denoted by P atmosphere is what? ATN. This is a denotation, notation thing. One more thing, its value is somewhat fixed at the Earth's level or at the sea level. And what is this value? And its value is approximately 1.013 into 10 raised to the power 5 Pascal. This value is at the sea level. This value is at the sea level. Sea level is what? Sea level is what? Sea level. So I think it's clear. What is the cause of atmospheric pressure? What is its value? So you can say P naught is about, I have mentioned the value. Now, why should I write it again? Okay, clear these things. Now moving further. Now again, this is the most important thing. The what's the heading says? Variation in pressure with depth. Variation in pressure with depth. I think every one of you knows the relation. I will describe it. In the previous slide, like this one, what we were discussing, pressure is uniform in horizontal plane. Horizontal plane. We were not talking about the vertical direction. Now, what we are talking about vertical depth, or you can say depth or height, whatever you want to say. Now, have a look at that. Just consider this is again a container which contains a liquid. I am considering a very small imaginary cylindrical portion, a very small cylindrical portion. One thing, this cylindrical portion is imaginary part. Like suppose this is a fluid, this is a liquid, and I am considering a imaginary cylindrical portion. It is just visible to me. Nobody else can see that because it's in my imaginations. Clear? If I consider a imaginary cylindrical body here, then what will happen? What will happen? There will be a force like suppose F1 is acting on the top surface and F2 is acting on the bottom surface. How I decide the direction of F1 and F2? Because this force is always perpendicular to the surface. So F1 and F2 is acting in this direction. Let's suppose pressure at the top surface is P and pressure at the bottom surface is P plus dP. What is P plus dP? It shows the pressure change. At the top surface, pressure is P. At the bottom surface, pressure increases slightly by dP. That I have assumed. Let's consider the height of the cylindrical body as dH. Again, if you are not aware, this D term is used for very small variations. dH is very small height, dP is very small change in pressure, like these. One more thing. What is this one more thing? This cylindrical body contains some liquid. Then it will have some mass. So its mass or its weight will act in the downward direction. And that weight will be mg. I have told you three things. Consider an imaginary cylinder. At the top surface, force is F1. At the bottom surface, force is F2. And the weight of the liquid inside it is mg. Clear? So three forces are there. The pressure I have assumed P at the top surface, P plus dP at the bottom surface, and dH is the height of the container, height of the imaginary cylinder. Now, can you see that this small portion of fluid is at rest? This small portion of fluid is at rest. What is the meaning of rest? That it is in equilibrium. That means all the forces acting on it must cancel each other. I will repeat my words again. Have a look at that. After changing the color of the pen, I will say in equilibrium. What is the equilibrium means? Liquid, or you can say fluid at rest. How many forces are acting on it in the vertical direction? You will say three forces are acting on it. Upward force, or you will say F net is equals to 0. What is the meaning of equilibrium? Ki net force should be 0. F net is what? One force is F2 is upward direction. Another force F1 in downward direction minus mg is equals to 0. Clear? I will place the values. Again, you know that P is equals to force per unit area. So force is equals to P into A. I will directly use force is equals to P into A. So what will be the value of F2? What will be the value of F2? You will say pressure. Pressure is what? P plus dP into area. Just consider the area as A. Consider the area as A. This is the area A. This is what F2. Minus F1 is what? F1 is what? Again, pressure into area is equals to mg. Clear? I think everybody knows that mass is equals to volume into density. This is very basic formula that you have learned in very small classes like 8th, 9th, 10th, whatever. So mass is equals to volume into density. Again, I will open the bracket. What it will become? PA plus dP into A minus PA is equals to mass. I am going to write the mass. Mass is equals to volume into density. Volume of this small imaginary cylinder. You know the volume of a small imaginary cylinder is? Anyone knows that volume of the cylindrical body? Pi r square h. I think it's correct. Into density is what? Rho. Density is what? Rho. So pi r square is nothing but the area of cross section. So it will become A H rho. This is mass. So m is equals to A H into rho. I will place the value A, and height is what? Height of the container, height of the imaginary cylinder is what? dH. A dH rho. This is the mass multiplied by G. Can you see something gets cancelled? This PA will cancelled by PA. So what will remain? dP into A is equals to A dH rho G. Again, A will cancel out. So change in pressure, dP is what? Change in pressure is equals to dH into rho into G. Now, let me explain each and every term. dH is the what? dH is what? Separation between 2 points. dH is what? Separation between 2 points. Rho is what? Density of the fluid. G is the acceleration due to gravity. The value of G is known. dH is the separation between 2 points. Rho is the density. So pressure, you will say the term comes positive. So pressure increases with depth. What you can conclude? Pressure increases with depth. If I say that total height of the container is h, total height of the container is h, and there is a point at the top and there is a point at the bottom. There is a point at the top, there is a point at the bottom. So what will be the pressure difference between these 2 points? Like this is point 1, this is point 2. At which point pressure will be more? You will say with the depth pressure increases, so at point 2 pressure will be more. What is the difference? You will say delta P, that is P2 minus P1, is equals to rho G. And what is the separation between these 2 points? You will say H. So general expression is the pressure difference between 2 points is rho G H, where H is the separation between those 2 points. Rho is the density of the liquid, and G is what? Acceleration due to gravity. So you need to remember this expression, that pressure difference between 2 points is rho G H. Take 1 minute of time. If you need to ask anything, you can ask. Clear? Okay. Moving further. Have you remembered the term? Just remember the formula rho GH. Rho GH is what? Pressure difference between 2 points. Now, there is a question for you. Hmm. First of all, try to remember some punchlines. Okay. Okay. We will discuss some punchlines here. Can you see the three? Can you see the image? There were three containers, or you will say three glasses, whatever you want to say. And with every glass at the bottom, there is a machine attached. If you clearly see, this machine measures pressure that generally used by uh, what you will say, um the persons who fills air in your bike or in car wheels. The same machine he used. He uses the same machine. It's a pressure monitoring machine. It's a pressure monitoring machine is attached at the bottom of each of the container. Clear? At which machine, at which this is suppose 1, 2, and 3. Which machine will show high pressure? 1, 2, or 3? Which machine, the pressure at the bottom will be higher? Can anyone answer? Okay, don't worry. I will discuss a punchline with you. The pressure, listen to me very carefully. The pressure depends on two things only, like this. The pressure depends on two things only. What are those two things? One is density, another is height. Another is height. So pressure depends only on two things, density and height, not on any other factor, not on any other factor, like this. Read the statement. What does the statement say? The pressure exerted by a liquid at a point depends on the vertical depth of the point from the top surface and the density of the liquid. It does not depend upon the shape of the container. Whatever may be the shape of the container, whatever the amount of liquid in it, but the pressure at the point depends only on the height of the surface, height of the liquid, and the density of the liquid. You need to remember this thing very clearly. I think it's clear. So, height of the liquid in all these three is same. Height of the liquid is same in all the three. If height of the liquid is same and liquid is also same, you can identify it by the color of the liquid actually. So liquid is also same. So pressure at 1 is equals to pressure at 2 is equals to pressure at 3. Try to remember this punchline. What you will remember? Pressure at any point does not depend on shape of the container and the amount of liquid in it. Depends on density, depends on density and the height from the free surface. Clear? One more thing. I will draw a simple diagram for you. Again, I am saying I am not very good in drawing the diagrams. This is a container. What is the shape? I don't know. This is a container. It contains some liquid like this. And there is another container. These are the two containers. They contain some liquid in it like this. Reply everyone. This is the point 1. This is the point 2. At which point you need to find the relation between P1 and P2. Which is greater, which is smaller, what kind of relation is there between these two? P1 is what? Pressure at the bottom of first container. P2 is what? Pressure at the bottom of second container. So which pressure is greater? Which pressure is more? Just reply in the chat box. I think time is ending now. It does not depend on the shape of the container. It depends only on the from the free surface. So free surface, height from the free surface is what? Same. So height from the free surface is same. So P1 is equals to P2. This is what the answer. I think clear. Next. There is another punchline. I think time is very limited. So I will end it here. Otherwise, some other classes may disrupt. Till then, bye bye. Enjoy and keep studying. Bye, everyone.